score 2 is over specific types of probability distributions called binomial distributions. So we're going to start with a little definition first. So in general, an experiment can have n outcomes or can have n trials they're listing here. If we have a binomial experiment, there are only 2 possible outcomes that can happen. So a lot of times we look at a binomial experiment instead of, 25 different things that can happen, or maybe let's just keep it simple. If you roll a dice, 6 different things can happen. Something like a coin is considered a binomial experiment because it's either a head or a tail. Those are the only 2 things that can happen. A lot of times we talk about like success versus failure when we're talking about binomial experiments. So if we have 2 outcomes out of our n trials, it's a binomial experiment. The probability of success, you're going to need to know these variables because they're going to show up in a formula in a little bit, is given as P. And the probability of failure is the complement of the probability of success, and it's going to be a Q. So let's say the probability of success is a 0.2, 20%. The probability of a failure would be a 0.8, 80%. They should always add to 1. The trials are going to be independent of one another, and then X is going to be our number of successes. Okay, and again, n is the number of trials that we have. So n is how many times we do the experiment. X is how many times we have success. P is the probability of that success on a single trial, and then Q is the probability of failure on that single trial. Okay. Good. All right. So let's look at a little example. So here we have a binomial experiment that consists of picking a card, determining whether or not it is a club. Okay, so picking a club would be considered a success. Anything other than a club would be considered a failure. And then replacing the card. So we want to find, for this information, N, P, Q, and X. So all those variables are going to show up in our formulas for this experiment. So let's start with N. N is the number of trials. So using the information on the left there, how many trials do we have? 5 trials. Okay. P is our probability of success. So let's say you have a deck of 52 cards and you are trying to draw a club. What is your probability of success? 13 out of 52, and then we usually are going to see these written as decimals, and actually that one's just 1/4, so 0.25. Q is going to be your probability of failure. So if P is 0.25, to get Q, all you have to do is 1 minus it, its complement, 0.75. And the only other thing we don't have here is X, and that's where we actually have to look at these trials that have happened on the side. So X is the number of successes. All right, so the first card drawn was a 10 of spades. Was it a success or a failure? Failure. The second card drawn, success or failure? Success, it's a club. Then you can see we have a heart, that's a failure, a diamond, that's a failure, and another club, that is a success. So our X here is 2 for this particular experiment. Okay? Any questions getting those variables? What each thing stands for. Good. All right. So I want you guys to work on these 2. It says determine whether each of these experiments is a binomial experiment. Remember, for binomial experiment, it means there are only 2 outcomes that can happen. If there are anything other than 2 outcomes, it is not a binomial experiment. If it is a binomial experiment, give N, P, Q, and then the list of all the possible values of X. So all the different ways you can have success, the number of successes. Okay, so take a couple minutes. Try these 2. You can work together if you want. All right, let's take a look at it. So the first one is a binomial experiment. 8 trials, probability of success is 85%, probability of failure is 0.15, and here it asks for all the different possible values that x could be. And remember, x is the possible number of successes. So you could have anywhere from 0 successful surgeries all the way up to 8 successful surgeries. And we'll put that information with the x's in a table of values in a little bit. The second one, it's a little tricky. It said you were not replacing the marbles. So that means from one trial to the next, it becomes dependent. It depends on what you took out from the first trial as to what the probability of the second trial is. The probabilities need to remain consistent from one trial to the next. So when we leave those marbles out, it becomes not a set of independent events anymore. So it is not going to be a binomial experiment. Okay. Any questions on either of those? All right, cool. Okay. Formula that you need to know is as follows. In a binomial experiment, the probability of exactly x successes in the trial is given as the following. So again, we're using P of x to represent probability of a certain event happening, x successes. This is what we're going to use most often because we have that button for C. Remember, in our calculators, even in the red calculator, we have that function. What you're seeing on the right here, that's just that C equation expanded out for our combinations that we saw back in chapter 3. So it's n choose x, and we're using a C because order doesn't matter. Then we take our probability of success, take it to the x power, our probability of failure, and take it to the n minus x power. Those two exponents will end up adding to your n value is how that works. Okay, and then again, this just kind of says all of those factorial symbols that you see on the right are just coming from that formula we saw before. Okay, so the little problem in the corner, you can see how this works. It says there's a 40% chance of rain for the next 3 days. What is the probability that it will rain exactly one day? So start by finding your N, your P, your Q, and your X, like we just practiced, okay? What's N? How many trials are there? 3 days. What's the probability of success? And here we're talking about success, meaning it will rain. That's what we're trying to calculate. So the probability that it will rain is 40% or 0.4, which means the probability that it won't rain is 0.6. And we are trying to calculate a specific x value here. Now here the x values range anywhere from 0 to 3, right? No days all the way up to 3 days. We want exactly 1 day. So that's the x we're going to use in the formula. Okay, so the probability that it's going to rain exactly 1 day is n choose x, so 3 choose 1, times our probability of success, 0.4, to the x power, 1, times our probability of failure, 0.6, to the, and you can write this out if you want to, 3 minus 1, or just kind of like the complement of that. It's going to have to add up to n total, or 2, whatever works. So this is pretty much saying I have 1 success and 2 failures. That's what our powers are telling us there. Okay, and then you just type it in your calculator. Remember, if you have the graphing calculator, if you want to find that combination button, it's under math. You hit math and then go over to where it says probability. You'll see it's like the 3rd or the 4th option down there. And that's going to be, if you have the red calculator, pretty much in the same spot. There's a probability button and you'll be able to use it. So 3 choose 1 times 0.4 to the first power and 0.6 to the second power. You should get a 0.432. Okay. So that is our binomial formula. Questions on the formula? Okay. This is the long way to do it. If you did not have this formula, you would have to figure out all the different ways it could rain. So I like this little kind of graphic here. We've got our little tree diagram getting us to this, but it could be sunny all 3 days, it could rain all 3 days, and you've got kind of all the different options that happen between. Then you would find the probability of each of those things happening, which takes in itself a little bit of time. And then you would have to pick all of the ones where it rains exactly 1 day. So there's one of them here, one of them here, and one of them here. You can see those all have a probability of 0.144. If we add all of those 0.144s up, we end up with that 0.432 that we just figured out. Now that's a lot of work, and there's only 3 trials in this experiment. So if you can imagine if an experiment had like 20 trials, what kind of diagram we would be talking about doing. So this saves us a ton of time. All right, you guys try this one with a deck of cards. And the probability of selecting exactly 3 clubs using your binomial formula. All right. N is 5, P is 0.25, Q is 0.75, X is 3 successes. So 5 choose 3 times 0.25 to the third, 0.75 to the second, or 5 minus 3 is where that 2 is coming from, 0.088. Okay. Questions? No. Okay. You do have a function in your calculator that will do the whole formula for you. The formula is not too bad, and you guys know you're going to have the formulas on your test. But there is a function in your calculator that'll do it all at once for you if you want to try it, if you have a graphing calculator. So these are the steps we're going to use. We're going to go to the DISTR, which is a distribution menu, and we're going to look for binomial PDF is the feature that we're looking for. So I'll pull mine up and you can see what this looks like. So right below your arrows, there's a button that says VARs. If you hit second VARs, you'll see it on there. And then we want the binomial one, where is my binomial one? It's down at letter A is the one I'm looking for. Binomial PDF is what you're looking for. Okay, so again, second VARs is where menu I'm in. Binomial PDF. Okay, and then it just asks you for all the information. So let's just use the last example that we did a second ago instead of a new example. So the last example, you had 5 trials. The probability of success in the last example was a 0.25. You don't have to enter the probability of failure because the calculator can figure that out. And then the X value that we're using is a 3. Paste it in, and there's our probability. Okay, so that can just kind of skirt around the actual formula itself if you have your calculator, or if you want to check your answer if you're doing your math Excel. Okay, make sense? Great. Okay, so we'll just skip over this one because we did one of those already. All right, so let's do constructing a binomial distribution now. Okay, so let's say if we know the value of X, we can now figure out the probability of that particular number of successes happening. Sometimes we want to create a binomial distribution, which is all the different values of X's that can happen and all the different probabilities for each of those X's. So we're going to use this example. It says in a survey, U.S. adults were asked to identify which social media platforms they use. The results are shown in the figure. 6 adults who participate in the survey are randomly selected and asked whether they use the social media platform Facebook. Construct a binomial probability distribution for the number of adults who respond yes. Okay, so first of all, there's a lot of extra information here. The only thing that we care about is how many people use Facebook. That's our success. If you use Facebook, it's a success. If you don't use Facebook, it's a fail. Okay, so let's figure out what our N, our P, our Q, and our different values of X's can be. So N is how many trials happen in this experiment? How many trials happen? How many people are surveyed? 6. That's all right. That's a trial. Every time they survey somebody, 1 trial. What is the probability that one person, each independent trial, will use Facebook? What is the probability that that person will not use Facebook? Do 1 minus 0.68, 0.32. All right, and then all of our different values of x's. So lowest possible value of x is what? 0. It's possible that none of them use Facebook, all the way up to 6. All 6 of them could use Facebook, depending on how our trials work out. Okay, so that's going to be the top of our table. 0, 1, 2, 3, 4, 5, 6. Then we find the probability of each. And there are 2 ways to do this. The first way you can do it, let's say I wanted to find the probability of 0, is I would use my formula with 0. So I would do 6 choose 0, 0.68 to the 0 power, and 0.32 to the 6 power. 0 successes, 6 failures. And then I could type that in and I can get that probability. So let me do that real quick in my calculator on here. And we'll see what that one ends up being. 0.68 to the 0 power and 0.32 to the 6 power. And we get a really tiny number, 0, 0, 1. Okay, so very unlikely. Number less than 5% is an unlikely event. Okay, and then you can just repeat the process over and over again if you want. You can just change the x's. That takes a little bit of time, especially if you have a big table though. So if you have a graphing calculator, this is another opportunity where it can maybe save you some time. So let's just say I want to find the probability of x successes happening, whatever that is. I'm going to edit my formula I just wrote. It would be 6 choose x. It's always 0.68 to the x power. X is my number of successes. And then 0.32 to the complement of that, kind of 6 minus x power. Okay, that you can put in y equals in your calculator. And you can get a table that will do all of the rest of this distribution for you. So let me do that. I'm going to go to y equals, clear out what I've got in there, and I'm going to put exactly that in. So in y equals, I'm going to hit my math. I'm going to go over to probability, and I'm going to select number 3. 6 choose x, just your regular old x that you used in algebra. Okay. Then 0.68 to the x power and 0.32 to the 6 minus x power. Okay, and that will account for all the different values of x that I have here. Once you have the equation in there, hit second graph, go into your table of values. And you're going to see, as you scroll up and down, the only values that you actually get a number for are your numbers 0 to 6. It gives you errors for the negatives, and then it gives you a probability of 0, nothing for anything above 6. So then you can very quickly just fill all those in your table. Drag it over so I don't lose it here. There we go. Okay, so I've got, what do I have? 0.014, if I give it 3 decimal places. 0.073, 0.206, 0.328, 0.279, 0.099. Okay, and then just like our distributions before, if you want to double check anything in the end, it's a probability distribution, so everything should sum up to 1 or be really close to it. Yes? Yeah, second graph.
I think it's just showing me like 2.21, 2.2.
Oh, you probably changed your table setting to something. Okay, hit second window. And then table start instead of 0. And then change in the table instead of 1. Now. There you go. Anybody else's table settings weird? Something okay? Something weird happening? Yeah, hit second window. Hit set. 0. Table start 0. Yeah, you're good. Yeah. Okay. Any other questions on that? Great. Okay. All right. When it gets to test day, you're going to see a couple problems like this. Applying the binomial probability formula. It says a survey found that 17% of U.S. adults say that Google News is a major source of news for them. You randomly select 4 adults and ask them whether that's true. What is the probability that exactly 2 of them respond yes, at least 2 of them respond yes, or fewer than 2 of them respond yes? Okay, so what is my n? Start with the same thing again here. What's my n? 4. What's my p? 0.17. So that makes q complement 0.83. And then x is going to change from one problem to the next here. So in the first problem, it's saying exactly 2 of them say yes. So my x is 2. Use the formula. 4 choose 2. 0.17 to the second, and 0.83 will also be to the second. 2 successes, 2 failures. Type it in however you want. Y equals your home screen, by hand with your combination formula, whatever makes you happy. Okay, 0.83 to the second. And you're going to get 0.119. Okay. Next problem says at least 2 of them respond yes. So what are the possible values of x now? If it's at least 2. 2 or 3 or 4. Okay, and I said the word or there. Do you remember when we did or versus and, what or means to do? Do we add or multiply our probabilities together? Or is when you add them together. Yes. So that's what we're going to do. We're going to do 3 separate probabilities with our binomial formula, and then we're going to add all 3 of these together because we're looking for there's 2 successes or 3 successes or 4 successes. All right, so the first one we already have, when x is 2, we know that the probability is a 0.119. We already figured that one out. When x is 3, we have to figure that guy out. And when x is 4, we have to figure that guy out. And we're going to add them together. Okay. Formulas are going to look just like above. So for 3, it's going to be 4 choose 3, 0.17 to the third, 3 successes, 0.83 to the first, and 4 choose 4 would be 4 successes and 0 failure. So you can just edit what you typed in previously, change those x values around a little bit. So for x is 3, I'm going to get 0.016. For x is 4, I'm going to get a really tiny number. Mine says 6.9 e negative 4. So that means times 10 to the negative 4th, which means my decimal is 4 spaces to the left. So I'm going to have 3 zeros and then 6.9 at least. And there's a bunch of stuff after that. Add them together. And I get 0.13 6 if I round it to 3 decimal places. Okay. Last part says we want to find the probability of fewer than 2. So fewer than 2 is what values of x? 1 or 0. We always want to make sure we include 0. Okay, now here's a shortcut. So you can find the probability for 1, find the probability of 0, add them together. Perfectly fine. Or what I'm finding now is the complement of what? The last problem, right? The last problem was 2, 3, 4. It was everything from 2 above. This problem is everything below 2. So we've got 2 distinct groups that total to everything in my binomial distribution. So I can use that shortcut if you see it. So it is the complement of part B. And if I'm finding a complement, I can just do 1 minus 0.136. And I get 0.864. Or again, you can find the probability of 0, the probability of 1, add together. It just takes a little longer to get there, especially when you maybe have a lot of different possible values of x's in your experiment. Okay? Questions on that one? All right. Last problem. So if we have a binomial distribution, a binomial probability, we can, again, find the mean, the variance, and the standard deviation. These are by far the easiest mean, variance, and standard deviation you will calculate. Look at these formulas. There's not even a summation in them. To find the mean, all you have to do is your n times your p, and we already know how to find n and p. To find your variance, it's n times p times q. We already know how to find all those 3 things. And then again, as usual, if I take the square root of the variance, I get the standard deviation. And that's giving me the mean, variance, and standard deviation of that table of values is what this is calculating for us, like that big one that we made. Okay, so it says in Pittsburgh, Pennsylvania, 56% of the days in a year are cloudy. Find the mean, variance, and standard deviation for the number of cloudy days during the month of June. Interpret the results and determine any unusual values. Okay, so I need an N, I need a P, and I need a Q. Okay, N is the number of trials. How many trials are there here? Number of days in June. So how many is that? Do you know the song?
No.
Yes. Yeah, Emily's right.
I learned
I learned it when I was little too, and I always sing it if I'm not sure. 30 days has September, April, June, and November. When short February is done, all the rest have 31. No? This is a life skill, guys. I still use it to this day.
Remember the periodic table song?
Oh, I never learned a periodic table song.
Way more complicated than the month song.
The month song. I know my quadratic formula song, but I use that one a lot, I guess. What else do I know? You know what I didn't learn? The 50 state song. And I feel like I should know the 50 state song. Do you know the 50 state song?
Mine was just stacked the states. That's how I did it.
The what states?
It's stacked states, like on the app store. So you would have to like literally like stack the states. Yeah. A state would drop and then you'd have to like stack. Yeah, you'd have to stack another like state on top of it, and that's how I learned geography. And like that was like 4th grade.
I'm trying to picture what you're exactly doing with the states.
Yeah, that's how
I'm just picturing like Tetris blocks dropping from the top and then the states like.
Yeah.
But how did that help you with geography?
You gotta guess what state it is.
Oh, it goes together. Which ones are next to each other?
Yeah. And so like a picture would come up and you guys are like, oh, that's Ohio. And then Ohio, it's like impossible to stack. It's just like
I feel like I need to download this app for my kids. Does it still exist?
probably.
Stack the state. All right, you look it up. You let me know. They'd like that. They get new apps on Sunday. They're allowed 1 new app every Sunday because otherwise it would be like a little crazy. So we'll do stack the states this week. All right, now that we figured that out, Probability of a cloudy day is 0.56. Probability of not being cloudy, so probably sunny, 0.44. All right, so our mean is n times p, 30 times 0.56. 16.8. So that's something we would probably round because we're talking about number of days here. So it really doesn't make sense to have like 16.8 days where it's cloudy. So you could say approximately 17 days will be cloudy. Variance, our little sigma squared, is n times p times q. We actually already have n times p, so you can just take that and multiply it by q if you want to. And we get 7.392. And then finally, my standard deviation is just the square root of that variance. About 2.719. Okay. If we were to interpret the results, we could kind of think back to what we were doing in chapter 2 with mean and standard deviation. We could say if my mean is 17 and my standard deviation is about 2.7, you could even make that about 3 if you wanted to round it. You could say that 68% of June will have between 14 and 23 cloudy days. So I took that mean and I went one standard deviation to the left, one standard deviation to the right. So I added 3 in each direction approximately, and that's where about 68% of my data is going to fall, or 68% of the Junes that we're looking at. And then you could take it a step further if you wanted to. You can go another standard deviation in either direction and say 95% of Junes will have this many cloudy days, and you could say another add on to those, 99.7 will have this many cloudy days. Okay, that's it. We're done with 14. Any questions? Cool. All right, that wraps it up. So 4-1, remember, is due, we'll just put all of our dates on here, tomorrow night. 4-2 is due on the 6th, Sunday night. Our chapter 3 test is going to be the 7th, Monday. Chapter 4 test is going to be the 8th on Tuesday, and the next 2 days in class we are going to review. Remember, your circuit training is also due on Monday if you're doing that bonus. Make sure you show the work for that to earn all your tickets. I'll take the last couple minutes here and I'll pass back. I have your projects, your first projects to pass back for you, the rubrics. And then I also have your test reviews. We're going to do the chapter 3 stuff on it tomorrow, but if you want to work on it ahead of time, you can. And then, like I said, you can check out that extra stuff I posted in Polaris for you. Okay. All right.